Okay, so if you're still here, we're in video 2. It says, please open up your Unit 4 iBook. I'm not going to quite do that yet, but we will visit ultimately. I just don't want to be bouncing back and forth too much. So I'm just going to fill in these blanks without using the iBook. A line, or excuse me, I was thinking about the next thing. A reflection is a rigid motion. All right, so let's say preserves congruency, and you will see isomorphic isometry. You will see those words every now and then. So a reflection, a rigid motion, it means it preserves congruency. I can never remember, is it preserve or preserves? I think it's spelled that way, but who knows. Thick. All right. Those are other words you'll hear, in which each point in the pre-image is the same distance from the line of reflection as its corresponding point in the image. So we're going to tap this link and we're just going to play around with some reflections for fun. All right. So let's load this up. Okay, so what I got to do is try to make each point here correspond to a point however you say. What I got to try to do is take these dotted points and match them to the line of reflections. And notice how it's hard to do without being able to point at anything, but the points on the red line and the blue dots are equidistant from the line of reflection. They match up. All right, so that's one. And we got some slanted lines. I know you guys are going to have different ones, but I think there's a way to get, I think if you just hit refresh, you can get different lines each time. But anywho, let's see, there we go. There's that one right there. And you can also use your mirror or your cell phone as a mirror to help you predict where these reflections will land. All right, it's not giving me, oh, there we go. Finally, an easy one. All right, you can keep pressing new until you get an easy one, or reloading, whatever that may be. Yeah, these ones are far easier. The horizontal and vertical lines significantly easier, but they're equidistant. You guys can play around with that as much as you want. But anywho, that's just a nice way to try to practice reflections. All right, what did you notice about the distance between each point and its image from the line of reflection? They were equidistant. And remember, the line of reflection is essentially like the midpoint. All right, it's in the middle. Essentially, not exactly, but essentially. All right, so now we're back in the iBook. So we're going to reflect triangle ABC over the y-axis using the understanding that in a reflection, each point and its image are the same distance from the line of reflection. When you are done, tap on the figure to check your work. We're not going to tap the figure because we're not in the iBook. But here's the line of reflection. So C is 2 to the right, so C prime will be 2 to the left. B is 7 to the right, so 7 to the left. All right, and you can even just tell by looking at the coordinates, like we're here 4, so A is 4 to the right, so A prime will be 4 to the left, and that's it. And just to clearly emphasize some things, so again, if you're good at counting, you're going to be pretty darn good at reflections. And I'm going to put highlighter marks. These are equidistant. The line from B prime to the line of reflection is the same as from B to the line of reflection, so on and so forth. All right, so in this unit, we'll be focusing on reflections of figures in the coordinate plane. When working with reflections in the coordinate plane, the line of reflection could be the x-axis, the y-axis, or any other line. All right, when we say any other line, primarily y equals x or y equals negative x. We're really not going to venture from those 4 lines. Okay? But now, what I really like about this unit is we got a bunch of cool gizmos. So we're going to open this in Safari, make sure you guys are logged in. Somehow I got logged out. I'm already logged in. So let's go to My Classes. All right. This is the one I want. Launch, please. There we go. All right, now I'm going to split screen with Notability. All right. So under figure type, we're going to select point. We already have that. Under operation, we're going to click reflect over the x-axis and then show table. All right. I really like the show table. All right. So we're going to drag point A up, down, left, and right. All right. So let's just start dragging it. Notice how if A goes up, well, E, which is the image, goes down. What happens if I go left? It follows it. If I go right, it follows it. If it goes down, it goes up. So, So when point A goes up, E goes down. When I go down, E goes up. However, left stays the same and right stays the same. All right. So watch the coordinates. Now we're going to do the same thing. I'm just dragging around A. We're going to watch the coordinates. So notice how the X values in A and E are always the same, but the Y values always have a different side. All right, so since this is over the X axis, X stays same, Y changes sign. All right, now we're gonna do, if point has XY, coordinates of XY, what are the coordinates of an image of XY if it's reflected over the X axis? So that's just gonna be X negative Y, right? So again, we talked about this stuff yesterday, now today, but it's good to see it on a second day, and now we're actually seeing it move live. All right, we're actually seeing a reflection occur in real time, which I really like. All right, now we're going to select reflect over the y-axis. This is interesting. When I go up, so does E. When I go down, so does E. When I go left, now E goes right. When I go right, now E goes left. All right, interesting. So up, up, down, down, left, right, right, left. And if we look at the coordinates, it's the same thing but different. Now X always has a different value, but Y stays the same. All right, X sign changes, Y stays the same. All right, so a point XY, what are the coordinates of the image if XY is reflected over the y-axis? Well, X is going to change and Y is going to be the same. All right, so let's see what we got here. Yep, this is what we're going to do. All right, I think I've set you up for a lot of success. What we're going to do is figure type triangle. Now to set up this triangle, A, 7, 5, so on and so forth, you're going to just drag A to 7, 5. Be very careful when you do it. We're going to take off the transformation from now. B is going to be negative 10, 2. So when I do this, I look at the table. I don't look at the graph because I think it'd be too hard to look at the graph and do it. Look at the table, and then C is 2, 8. 2, negative 8, excuse me. All right, so I set up my triangle. Now I'm gonna, this one, I'm reflecting over x-axis. Over here, I'm reflecting over y-axis. I want you to do it and then check your work, all right? Operation, then you can do it and check your work. Then you're gonna go back to the iBook and you're just gonna knock out the rest of these notes. It's just some logic problems again. performing reflections, and you got your canvas problems. All right, I think we're set up for success where we can knock these out. Have a good rest of your day.